So now let's talk about a rational inequality. And what's so different about a rational inequality is really not that much. In fact, we will be doing exactly the same things that we were doing, following exactly the same steps we were following in solving a quadratic inequality when we solve a rational inequality. And the only difference is that all of our factors can be in the numerator or denominator of the fraction. We definitely want to set the inequality to 0 because all we're really interested in is whether we're taking a positive and a negative factors right here and comparing it to 0. That's all that really matters right here. So when we have all of our linear factors, we're going to mark those on the number line. So let's go ahead and do that now. Here's 0, 1, 2, 3, 4, 5, and so on to the right. Here's -1. Here's -2, -3 to the left, and so on. So we find all of the zeros of each of our factors. So we would say that the factors equal 0 at, and these ones are pretty easy to determine, x equals 2, x equals 3, and x equals -1. So we mark these zeros on the number line right here, and I'll mark them in blue. We've got -1 for x plus 1. We've got +2 at x minus 2, and we've got +3. Now we've got the number line divided into 1, 2, 3, 4 separate intervals. And so what we're going to do is we're going to set up our test intervals. And we want to test to see if the interval from -infinity to -1, possibly including -1 as part of the solution set. We're going to see if the set from -1 up to +2 is possibly part of the solution set. We're going to see if the solution set involves the numbers between 2 and 3, up to and including 3. And we're going to see if the set from 3 to infinity will satisfy this inequality. So we should choose some test values from within each of these intervals. So in the first one, that's not too bad. We're going to choose -2 to test. Well, at x equals -2, what happens? We get, in our original inequality, -2 minus 2 times -2 plus 1 divided by -2 minus 3. And we want to find out, is that less than or equal to 0? Well, in this case, we're going to get -4 in the numerator. We're going to get -1 in the numerator. And we're going to get -5 in the denominator. Well, the overall result is -4/5. That's +4 over -5. And that is less than or equal to 0. So that's true. And so this part of our solution set will be included. Everything to the left of -1. Pardon me, -1 here. Put that in the right place. And so now we ask, well, what happens on the interval from -1 to 2? Now let's choose 0. What happens at 0? Well, if it works at 0, that means that 0 minus 2 times 0 plus 1 divided by 0 minus 3 is less than or equal to 0. Is it? Well, in this case, we're going to have -2 in the numerator. We're going to have -3 in the denominator, and that's +2/3. And +2/3 is not less than or equal to 0. So that's not true. That's not part of our solution set. How about this interval from 2 to 3? Well, there aren't any whole numbers there. What do we do? Well, if there aren't any whole numbers, we have to pick a number between these two. So let's pick a number like 2.5. 2.5 is the same thing as 5/2. So we would have to test 5/2 in our interval to see if that's correct. Well, at x equals 5/2. Let's see what happens. We're going to get the quantity 5/2, that's 2.5, minus 2. times the quantity 5/2 plus 1 divided by the quantity 5/2 minus 3. Now, I'll tell you, when it comes down to it, we don't really have to know what these numbers are when we work them through. We can work them through, but I will tell you that if you take 2.5 and you subtract 2, you're going to get a positive number for this factor right here, 5/2 minus 2. If you take positive 5/2 and you add 1, you're going to get a positive number as that result. Then we look at the denominator, 5/2 minus 3. 5/2 is not larger than 3, right? It's less than 3. So that's going to give us a negative factor in the denominator. If we take a positive times a positive and divide it by a negative, the result is a negative. Whatever that negative number that is, that's true. And so this is in our solution set, so we would include everything from 2 to 3. All right, let's try it at x equals 4, and let's see what happens there. Does it work? Well, if we put in x equals 4, let's try and do the same kind of analysis. Let's look at each of our factors right here. We would have 4 minus 2 as a factor, and that's a positive number. We would have 4 plus 1 as a factor, and of course that's a positive number. And in the denominator we would have 4 minus 3, and once again that's a positive number. Is a positive times a positive divided by a positive less than or equal to 0? The answer is no, it isn't. So that is not part of our solution set. So our solution set, written in interval notation, will look like the set from negative infinity to negative 1 union with the set from 2 to 3. Or, pardon me, that's a square bracket right there. If I use set builder notation, here's how I would write it. The set of all x such that x is less than or equal to negative 1, or x is between 2 and 3. Either way, we're done. More in the next video.